All right, so we have one more thing that we want to discuss, and this is Fischer projections. So these are often used in biochemistry. When it comes to sugars and that kind of thing. We don't have to worry too much about it, but we just need to know what Fischer projections are and how to determine the orientation, right? Whether they're R or S. And so let's go ahead and take a look at a Fischer projection. So it might look something like this. Right, so it's just like a skeletal structure, just drawn a little bit different, right? These three spots all represent carbons. Of course, we don't have to explicitly place them in there. They just represent carbons, right? That's how skeletal structures work. And then if we think about these carbons, this carbon right here and this carbon right here are attached to four different things. And so these are chiral centers. And so we want to know how to read these Fischer projections to figure out whether they're R or S, right? And so the way this works is if you have a Fischer projection, right, it's always this kind of plus sign. We're going to call these groups A, B, C, and D. All it means is that the top and the bottom are kind of going into the back of the board, while the ones on the side are coming out of the board, right? So let's go ahead and take a look at this top chiral center up here, and let's determine whether it is R or S. And so the first thing we have to do is we have to identify our priorities, right? And so we have hydrogen over here. Hydrogen is generally always going to be number 4, and that's true in this case as well. We have a direct oxygen right here, so that's going to be number 1. And then we have a carbon and a carbon. This carbon is connected to 2 oxygens, while this one is only connected to 1 oxygen. And so this one wins out as number 2. And then this one down here is number 3, right? So we have our priorities. And so to solve whether this is R or S, we're going to go ahead and use our right hand rule. And so if you put your right hand flat on this image, what you'll see is your thumb is sticking out this way, and then your fingers are pointing out, right? Really fat thumb there, but that's okay. And so you can see, right, when your hand is nice and flat, you're starting off at number 2. And then you're going to go ahead and curl your fingers, right? Remember that this OH is sticking out of the board. So when you curl your fingers into the back of the board, you're not going to hit that, right? Once your hand is perfectly curled into kind of a fist, you're then going to hit number 3. And then in theory, if your fingers could go through your palm, right, you'd end up back to number 1. Here we're going in ascending order, right? 2, 3, 1 or 1, 2, 3. So that is going to be R. Right? So that stereo center is R. Let's go take a look at another one. Right, so in this case, we only have one chiral center, right? That carbon right there has 4 different things. And go ahead and try to figure out the chirality of this. Maybe pause the video. So again, we want to identify our priorities. Our hydrogen is going to be number 4. Our directly attached oxygen is going to be number 1. And then this carbon up here is attached to 2 oxygens essentially. So that's number 2. And then this is just a CH3. So that's number 3, right? And now again, what you're going to do is you're going to line your right hand with your thumb pointing towards priority number 4, right? So there's your thumb right there. And then your fingers, right? And if you think about, if you place your hand right up to your screen, right, what you're looking at right now is the palm of your hand, right? And so obviously we're starting at number 2. That's where your fingers are resting. And then when we curl in, right, remember that this is actually a wedge. And so then you're going to hit number 1. And then finally, when your hand is in kind of a closed fist, then you're then going to hit number 3, right? So 2 to 1 is a descending order, or 3 to 1 is descending order, right? And so since it's descending, we go with S, right? So do a couple practice problems and know how to read Fischer projections and tell whether they're R or S.